So let's start your snap interview for RCC as you have interview for Central Pollution Control Board. So first of all, introduce yourself.
Uh, Thank you, sir, for giving me the opportunity to introduce myself. I am Prashant Rawat. I hail from Chamoli district of Uttarakhand. In academics, I have completed my graduation in civil engineering from NITIE Uttarakhand. Sir, I
Okay.
also completed a project during my college, which was based on modeling of cement microstructure using various softwares. Sir, I have cracked GATE examination in both civil and environment engineering. The best I got is an All India rank 37 in environment engineering. Sir, in extracurricular activities, I have held the important position of technical coordinator in my college council. And in technical experience, I have undergone a vocational training of 2 months in NTPC's runoff river project in Joshimat, Uttarakhand. That's all. Thank you, sir.
Okay. So you belong to Uttarakhand, right?
Yes, sir.
तो जोशीमठ कौन से अर्थक्वेक जोन में फॉल करता है प्रशांत?
Yes, sir. Joshimat fall in earthquake zone 4.
जोन 4 और जोन 5?
Uh, sir, zone 5, sorry.
जोन 5. Okay. So my first question to you, what is the need of providing the doubly reinforced beam?
Yes. Sir, doubly reinforced beam is has a lot of applications. It is usually provided when the our applied force, our applied the bending moment caused by external forces more than the limiting moment for singly reinforced, because we cannot design an over reinforced beam as per our IS code. So in that case, we go for doubly reinforced beam. It has other application also. It is better suitable against reversal of load reversals. Also, sir, it can reduce the headroom clearance. It can give us more spaces. So these are the three reasons why we use doubly reinforced beam or prefer it.
Okay. So which one beam is more economical, singly reinforced or doubly reinforced?
Some more economical is singly reinforced beam because the amount of steel used in doubly reinforced beam is higher, and steel is more costlier than concrete.
Okay. But on other hand, if amount of steel is more, it will increase the ductility of the section also. What do you think?
Yes, yes, pardon.
On other hand, if the amount of steel is more in
Yes,
doubly reinforced section, then
yes.
definitely it is increasing the ductility of the section also.
Yes, it is increasing ductility of section also. The section is going to be smaller in size also, but the cost of steel will overweigh all of that because steel is much costlier than concrete.
Okay. What is the design stress for steel?
Yes, sir.
What is the design stress for steel?
Design stress for the steel. So
Hmm,
steel is designed based on the yield stress.
hmm. Yield stress.
Yes, sir.
Yield stress is design stress or what do you think?
Yes, it is yield stress which taken as means we apply a factor of safety over steel design stress, and then it becomes the design yield stress divided by factor of safety Fi, which is, yeah,
What is
1.15.
1.15? Okay, this is coming to be 0.87 FI.
Yes, a 0.875.
How will you define the yield stress?
So yield stress is the defining point beyond which the plastic behavior, the steel start to show its plastic behavior, and it goes large strain after it. Before it, the steel shows a linearly elastic behavior as per the design code of IS 456.
What is the maximum compressive strain in concrete due to bending?
Sir, maximum compressive strain due to bending is limited up to 0.0035.
Okay, and what is the maximum strain in steel?
What maximum steel, sir, it is defined, it is 0.87 Fy by Es plus 0.002.
Are you sure?
Yes, sir. So it
But
is,
I,
yes, sir.
he says, go ahead, Prashant.
Yes, sir. So it is
Okay,
the value for means this is the maximum value of the steel, maximum strain in the steel.
so this is a maximum strain. Okay, this is a maximum strain or a minimum strain? What do you think?
The minimum value of maximum strain, it is I can I can format it like it is minimum value of maximum strain in steel.
So you want strain in steel should be greater than this value
Yes, sir.
or less than this value?
The greater than. This should be greater than this.
Okay. So this strain formula, this strain we want, otherwise steel will not be yield. So this is applicable for all grades of steel or for a particular grade of steel. What do you think?
This strain value is um, I think so this is applicable for all grades of steel. Although Fe250 have a definite yield point, other two doesn't, but the formula will be same, I think.
Can you draw the stress strain diagram and show to me?
Just I how can I draw here?
So you can draw on paper and show to me.
Okay, okay, sir. Yes, I have drawn it.
Okay, just hold on. Let me. This is for the Fe250 and this is for the Fe415. This Fe250, where this upper yield point, lower yield point?
Yes, sir.
In Fe250 grade,
Uh,
isn't there any upper yield point, lower yield
Yeah,
point?
there are upper yield and lower yield point, but I am showing you the design curve, not the actual curve. We actually simplify our design curve in this case.
Okay, now what is the strain corresponding to this Fe250 if we want this Fe250 is yielding?
The strain, so it will be it will be the definite yield point strain will be, I think, um, so it will be simply stress divided by strain, no, Fi divided by Es, or we can apply that factor of safety, then it will be 0.87 Fi by Es.
So how this formula is valid 0.002 plus 0.87 Fy upon Es for the mild steel also? Are you
Uh,
getting?
yeah, I am getting your point, sir. I think I know it, but I'm unable to describe it at the moment. Sorry, sir.
Okay, no issue. Can you tell me what is shear center?
Shear center, so shear center is a shear center that point at which if shear force is applied, then beam will show no torsional movement, torsional reaction.
Okay, this is a point where this if we are applying the shear force, right?
Yes, sir.
Okay. How will you apply the shear force on the beam?
So sorry, transverse force. I mean transverse loading, not shear force in that sense. Transverse.
Transverse.
Yes.
Okay. So if we have a unsymmetrical section like this one, we have only one axis of symmetry.
Yes, sir.
So can you tell me on what axis this shear center will lie?
Yes, shear center will always lie along somewhere on the line of symmetry, and here in this case mm, it is point R, which is a shear center.
Okay, good. Now suppose if torsion is acting on your this RCC beam, so how
Yes.
will you tackle the torsion?
So for torsion, the code asks us to, there is a separate design concept for the torsion. In that case, we use more shear reinforcement as well as more main reinforcement. We basically convert our torsional movement into bending moment and shear force. So then there we generate new bending moment and new shear force, equivalent bending moment, equivalent shear force, and we designed it same as we design a normal bending beam and a normal shear force, but the new steel will be added on both shear reinforcement as well as bending reinforcement because of the torsional moment.
How will you calculate this equivalent shear?
Equivalent shear, it is there's a formula, so V plus V, which is normal shear force, plus 1.6 T divided by B.
Is it okay?
Yes, sir.
Okay, fine. So can you tell me what is the maximum cement content for RCC work?
The maximum cement content for RCC work is 450 kilogram per meter cube.
Okay. Now I have this 55 cubic meter concrete quantity. So can
Yes,
you
sir.
tell me the number of samples that we have to prepare?
4 samples, sir.
4 samples. So in one sample, how many cubes that we have?
Sir, in one sample we use 3 specimens, 3 cubes.
3 cubes. Okay. My last question to you.
Yes, sir.
Can you tell me this? What is the modular ratio?
Yes, sir. So modular ratio is basically one of is what a concept used in the designing and analysis of beams. It allow us to design or analyze a composite beam as a uniform section. Here, what we do is transfer one of the material which is used in compressive strength into other. The formula given it's a ratio of modulus of elasticity of one material to another material. For in if we are using in RCC, then its formula is modulus of elasticity of steel divided by modulus of elasticity of concrete. So this concept is specifically used in working stress method design philosophy.
Okay, so can we use the same in the LSM also?
So we use it in LSM also, but we do not. But that's a different thing. We also use the no. So we do not use modular ratio in LSM. That's LSM has a separate different style of designing or analysis.
Okay.
We use it in pre-stressed concrete though.
Okay. What is the code for the pre-stressing?
The code for pre-stressing, sorry, sir, I do not remember. Like,
Okay. Okay, so let me give you feedback.
yes,
See, Prashant, your technical is okay. There's no flaw in your this technical skill.
yes, sir.
Okay. Here you just got a little fumble. कि ये maximum strain है, although that was a minimum strain that we are requiring. कि
Yes, sir.
concrete में sorry steel में at least इतना strain होना ही चाहिए because we want steel to be yield.
Yes, yes,
Strain
sir.
in steel should be greater than or equal to this value and this formula is applicable for the grade of steel higher than 250 ना क्योंकि 250 के
Okay.
लिए तो डायरेक्टली strain value है हमारे पास.
Okay, so I मतलब मुझे थोड़ा आइडिया था, बट वो हल्का सा
हम्म,
रिवीजन नहीं था, तो वो निकल गया
हम्म,
नहीं। वो
बाकी ठीक है बाकी.
प्रूफ स्ट्रेन है ना सर, वो 0.002।
दैट इज द प्रूफ स्ट्रेन.
ये सर वो
आपका
सर थोड़ा
इंटरव्यू
सा
है
कर।
1 तारीख को राइट?
यस सर।
एनीथिंग एल्स यू वांट टू आस्क?